Right now, there's been a big influx of interest in machine learning and especially large language models. One of the key concerns in making sure that a model is trustworthy is when it's going to work and when it's not going to work. It's like always the user's fault in a sense, right? If the system didn't work the way you wanted to, learn how to prompt it better, or wait and hope that a company trains their model that happens to be better for your task. It's always fascinated me that traditional machine learning always assumes that the world is effectively static. The ways that we use language change over time, and models that were trained yesterday might not be that good at detecting new types of toxicity today. And as our models get bigger and bigger, it gets much harder to update them. That's a challenge that isn't going away anytime soon. So how can we efficiently add this new information to our existing models and let them keep adapting? I don't think that these models are trustworthy when people are actually trying to use it for some task and they discover that it made some sort of mistake. Today, they just lose trust in the system, rightfully. But with some of the methods we've already developed and are continuing to develop, they'll have ways to say, I noticed a mistake, I didn't like this behavior, now I've fixed that targeted behavior in an efficient way that's just personalizing the model to their own needs and trusting their expertise. In order to make anything actually useful, it's critical to incorporate the end user. My students are consistently interested in critical evaluations of existing systems, the relevance of new data sets that the community heavily relies on to claim progress. We're looking at the differences between an extremely popular medical data set that is derived from the United States medical licensing exam that many companies use to evaluate the quality of their medical language models. The companies are reporting 90% accuracy. And we're finding like 30% accuracy when you actually go and you check to see what happens when you run the same models on real patients' data. It's crucial to know about these gaps because it's high stakes for patients whose providers may be making decisions on their behalf using their data. I care a ton about the veracity of the claims. I'm a faculty affiliate at UVA's Comprehensive Cancer Center. There are clinical trials happening all the time that are teaching us more about how, say, different treatments are impacting different groups of patients. There are not currently good ways to take those new findings and put it in the hands of patients and their care providers. So cancer survivors, for instance, all of their general purpose healthcare needs will be filled by a primary care provider. And so we're building tools to pull the new evidence automatically and then try to reframe it in ways that are understandable for generalists. And we're working on filling clinical knowledge gaps, both for patients and for providers. I think about how our work impacts others all the time, whether it's within the machine learning research community, trying to increase rigor and evaluation practices, or with my work at the Cancer Center, working closely with people who are actually providing active care to patients when developing the methods that we work on. The role and scale of data are bigger than ever, and it continues to increase. And with that comes all the tools to be able to process all of the data. There's huge opportunity to harness these tools in more and more avenues, hopefully for a social benefit.